to, because how in data engineering we are having some certain kind of the terminologies. Similarly, we are having some sort of common terminology. As I said earlier, guys, the standardization is something like which is acceptable by everybody. Okay, so that particular standardization is a aspect where you can depend, and once you learn means it is fixed. There is no change. It's not like in one company a machine learning different is like machine learning context is this way, and then another way it is in another way. Not like that, guys. That is the advantage of any programming language or any learning. So just whatever the programming languages, whatever the aspects we are practicing, all those kind of the conventions, okay, are very much useful for us. And as far as this session is concerned, as there are no presentations today by the members, so just we'll divide this particular aspect in this way, guys. The very first thing is, as I said, ML context we'll see. In this particular case, what is learning, and how many types of learning, and along with these kind of the learnings, we're having some sort of supervised, unsupervised, and most frequently used kind of the thing, guys, in the supervised learning. I'll be discussing classification and regression. Classification and regression. And let me see how I can scope this thing also on supervised learning. And here we are having clustering, principal component analysis, association rule mining. And at times, guys, dimensional reduction, all those things comes under the category of this unsupervised learning. And once these topics are over, so just we'll jump into the Databricks practice. So daily we'll see this particular practice, friend, so that you also have some understanding, like it is something like whatever the topics we have covered, and those topics, in what way they are asking the questions, all these kind of the conventions can be specified. Okay, so now let us start into the context of understanding the machine learning. So friends, can you give the specification? So if I'm asking you guys, why we need to learn basically, why learning? Why machine has to learn or human being has to learn?
To
Because
solve a particular pro- problem.
okay, very good. To solve a particular problem with our experience, na?
Right.
With our experience. Okay, very good, very good. Who is that? Who is that?
Sir, Sasikant.
Hmm?
Yes.
Srikanth.
Shashikant.
How are you, man? Oh,
Good, good. Thank you, sir.
good, good, good. Yeah, see, Shashikant. Yeah, Shashikant. Yesterday I asked, and I can see, if machine learning, if I am talking, definitely the analyst and machine learning people come into the picture, right? Yeah, yeah. That is the reason I
Definitely.
have chosen this in between, actually. Okay, and most importantly, guys, like any person's capability, depending on his or her experiences, and as well as along with that experience, the proficiency or performance. Okay, so and in what way is getting the results, accuracy of the results. Now let me put in this way, guys. Suppose I want to perform a particular task in a particular time T1 with the specified performance. Now, in terms of the machine learning, what happens is if you are making use of the task, okay, it is taking some time one, and we are executing that particular task for the first time, it is giving performance 1. Similarly, for the second time, it is giving performance 2. Like that, it is giving performance n. So what happens is if I am running the same algorithm multiple times with a different data, okay, whatever the data I'm giving, just it is your model is taking that data and it is learning from the data. Friends, here learning means, okay, experience. Okay, learning means experience. Now see guys, so there is a position, project manager or team lead or leadership. Okay, very rare case will prefer a graduate to place into that uh, position. Okay, a simple reason, but very rare case I said that. It doesn't mean that every case. Maybe sometimes, you know, we can see youngest CEOs and they're also with a high IQ and high balance in their decision making. We can we are now seeing leadership kind of members with a very 21 22 years also we are getting the members who are really doing well. They are all rare persons, guys. Okay, but if you consider in general why we are preferring the experienced people and all is they would have seen various issues. Friends, see, if everything goes right and you are having good team and your company is good and every resource you are making use in a best way, then it is obvious to get the productivity in a simplest way. But there are situations where your team members are not that much skillful and client is very challenging. And in that particular case, utilization of your team members and provoking them and guiding them in a better way is a challenging task. So that is called the experience, guys. Experience is not like moving day by day and as well as whatever the situations come will take. That is not the experience. That is something like you are moving ahead with the time. That's it. But your learning definitely plays a vital role. So that is the reason if any situation arise, in our case also human beings also won't react to this in the same way. Reason is based on their experiences, maybe how to solve this particular issue, and they can put up their learnings into that particular case and they can come up with a nice analogy. Here also, while performing a particular task, your performance of the algorithm is increasing after running every time. So every time if you are running that particular task, at a particular moment, you may be getting some optimized kind of thing. So this is what you call the learning actually. So giving some kind of various experiences to the algorithm and expecting kind of the algorithm is nothing but the learning. So, but why we need to learn means to get some kind of the insights and all those kind of the conventions and how we are utilizing the opportunity of empowering of our algorithm is most important thing. So put in a nicely neat compiled way, composed way. So just you see here, guys, learning is used when humans expertise doesn't exist. Humans expertise means, guys, if I am asked to train some 50 members, I can train. And if I need to mentor 100 members, I can mentor. But at a time, 1,000 members, 2,000 members simultaneously attending and handling those things, these difficult. We can do that, but still difficult. So where there is a lack of human expertise, so humanly not possible to maintain that particular convention. In that particular case, definitely we need to use this learning process. Humans are unable to explain their expertise. Friends, simple. I'm I'm having expertise in computer science and engineering so that I can talk artificial intelligence, machine learning, big data, all these things. But whereas maybe Akhil maybe background of ECE or Triple E, he can talk about electronics or all those kind of the things. So there is no, I mean, there is no commonality. There is no commonality of estimating the expertise of the corresponding things. Maybe some people are very good at storytelling. Some people are very good at explaining our Puranas and all Upanishads and all these things because their interest is that. So obviously they are able to explain the things in a narrative way. So solution change in time. This is the most important thing, guys. Like time changes, automatically the appropriate solutions or whatever the results we are getting may change. And solution need to be adopted to particular case. See, guys, all these particular 4 points, human expertise not sufficient or doesn't exist. Humans are unable to explain their expertise on every aspect, and solutions change in time because if I'm having client, okay, maybe Uber, so just their requirement and their aspects are different, their asks are different because completely that is management of one app where people are continuously raising their request so as to book the cabs and cancel the cabs or all these kind of the convention. Whereas if I'm talking about some kind of a Wipro, so where their thing is different. They need some solid preparation of the candidates in terms of programming languages and their thing is like implementation of the projects. Okay, and every fortnight cadence call like that, and their outcomes or deliverables are different. So it all depends on time frame and as well as the client based. Though we are using the same kind of the technology and the same technology may not be utilized same by all the companies. Okay, different companies are having their own kind of the requirements. We cannot address through the same kind of the platform. Okay, there are certain areas where we need to handle the things. Suppose if you consider Wipro and all, they are still using Hadoop 1.x only. Okay, because they don't want to maintain multiple name nodes and they are happy with that MapReduce aspect, MapReduce version 1, and they are not going to I mean they are not going to use that ARN or MapReduce 2 or something like that. So in that case, as their ask is that one, so we cannot say that oh we are moving to Hadoop 3, but why you are still with Hadoop 1? Okay, because their ask and their expectation is that one only. So the solutions change in time and solution needs to be adapted to a particular case. And for the medical domain, I cannot take the chance of 76 or 77 percentage of the accuracy. Rather, friends, just we need to expect or we need to ensure that 98 or 19 percentage of the accuracy must be there. So, and in banking, and as well as the insurance domain, mechanical, everywhere there is a certain benchmark, and based on that particular use case only, you are able to handle that accuracy, precision, and all these kind of the points. So learning is beyond the human control. Okay, I mean, if human cannot and ensure that this is the understanding of mine, and if he cannot, if he is unable to explain what he understood from that particular case, then we have to dependent on this particular learning. So now let us consolidate all the things, guys. We are conformed with why we need to learn. Now our interest is how we are making use of this particular machine learning. Yeah, this is quite interesting. Uh, Getting the computers to program themselves, let the data do the work instead, automating the automation. Friends, here, see, suppose I am mentoring a person, and I want to test him in technical, functional, and in a generic way, general his habits and all these things. Now, technically, I am teaching him some sort of big data, maybe Spark or something. And functionally, so I see what is his attitude and whether he is disciplined or not, how he is responding to the calls, all these kind of the things. Generic way. Okay, if no observation is there, and how he is behaving with his friends and all, and in what way he is behaving on all these things. So definitely it gives that as a complete product information, and based on that particular thing we can mentor or counsel them. So first we need to observe. Okay, first we need to give the chance to this particular human being or whatever the venture you are doing. Then after observing those particular things, based on that particular aspect, you can raise the bar. Similarly, getting the computers to program themselves. Okay, here you may be little confused, guys. Okay, the people who are in the practice of machine learning may be getting the sense, but whereas so other people who are having the background of DE or some other may be little bit confused. But don't worry, just after 1 or 2 minutes, your questions will be answered definitely. So getting the computers to program themselves. That means we are giving some data, and we are giving all the experiences of this data to the algorithm or machine, and we are expecting to generate a model for us. Okay, we are expecting to generate a model for us and let the data do the work instead. So here, friends, that's what I said. Your data set and your data pre-processing skills, and as well as some kind of the scikit-learn library, so as to adopt the algorithm. And based on these particular uh, parameter tuning, all these things gives your model. So model is nothing but the outcome, and based on this particular outcome, that means this model is designed by the machine itself, guys. Machine itself, in the sense there is a logic where some sort of the pre-processing techniques are available in terms of missing value imputation, in terms of feature engineering or encoding techniques, scaling mechanisms, normalization and standardization, all these kind of the conventions. Now the algorithms. So this today's session, I'm going to introduce at least 10 to 15 algorithms, guys, so that each and every algorithm is unique. They're having their own potentiality. So according to the requirement of the application, you can perform the you can select the corresponding algorithm. Now the parameter tuning. Friends, here after observing, as I said, if you examine a particular user or a particular learner, and after getting his attitude or activities, definitely we can fine tune those things, provided if he is ready to change, if he is ready to go to the new heights. But algorithm here is a machine where machine is no, it's not providing any its own kind of the functionalities, guys. In what way you are guiding, in what way the data set is based on the data set kind of the thing, it simply observes that, it simply observes, and accordingly it is learning from the data, and it is going to generate the program. Okay, so that means what happens here is, guys, just if you are making use of the data set, that is the reason why we cannot say this algorithm is good out of those all algorithms. We can say that this algorithm is best fit for text mining. This algorithm is best fit for the categorical data. This is best fit for the text data, like that we can say. But there is no concept where I can upfront say this algorithm is doing really well compared with all the algorithms, because it all your data, guys. It's all your data, and based on that particular data only, our algorithms are going to generate the model. And of course, those models are giving us some kind of the metrics, and accordingly, I can fine tune the parameters so as to reach the best performance. Okay, so this is one environment, guys. Actually, for the machine learning engineers, compared with the IoT, compared with the network security guys. Machine learning mindset is completely different because we are always in the observation of the logic. Okay, so while dealing with any kind of the algorithm, we have to be very detailed. Some people, guys, in Teams meet also, what they do is if I'm proposing something and they start conversation into the detailed. What is your proposal? What is your plan of action? And whether we are having the capability, or else if capability is not ready, then how we are going to train them. So these questionnaire, these detailing definitely helps so as to come up with some kind of the analogy, and which will leads to some kind of the better performance. Okay, throughout the discussion. Okay, now in this particular case also, guys, automating the automation. Really, this machine learning, we are not going to sweat anything, guys. After some time, after introducing some set of the algorithms, I will show you some code snippets so that you can easily grasp that. Okay, so with the understanding of the Python and scikit-learn library, you can easily become a machine learning engineer. So because with your efforts, definitely you can achieve anything, guys. But one good news is in terms of machine learning and all these kind of the genres, lines of code is not that much heavy in Java or any other typical programming language, because all these particular things are available. Only the thing is we need to make use of those things accordingly. Okay, and you may ask me this question: if all are fixed, then what is our efficiency? That's what I'm saying. The data scientist or machine learning job is um, to get the detail about the corresponding implementation. That is what the reason, guys. If you observe the typical data scientist team, okay, or data science team, so just there are a set of subject matter expert, statisticians, data engineers, data analyst, machine learning developers, and data scientist. See, whereas if I'm talking about some any other Java based kind of the development, maybe that is a web development or maybe some sort of servlets or EJB kind of thing, there are purely Java developers would be there, maybe junior, senior, or something like that. So here, whatever the programming language we are using, and one more important thing, your data science projects are not led by a single person. Of course, it is true for all the projects, but again, in this particular case, because decision making is not depending on the single person or two or three persons, because there should be a statistician where he can guide us. Okay, this is the hypothesis, then this is the p-value, whether we need to accept or reject the null hypothesis or something. Or else sometimes we may deal with the metrics, maybe root mean square error, root absolute error, R square, adjusted R square. Based on the outcome, he should suggest us what is the takeover here. Like that, the subject matter expert who really having the knowledge on the domains. So based on that particular domain, his domain expertise, he can guide us in such a way that okay, if this is the accuracy and if this is the kind of true positive we are getting through confusion matrix, whether we have to stay with this thing or not. So these kind of the things are handled by the subject matter expert. Whereas your data engineer, so just is helping us in such a way that just loading the data, pre-processing the data, and fine tuning of that particular data if any null values are there. Or maybe we can ask them to normalize or standardize the data. Okay, and then data analyst, who is the entry level kind of the member. Okay, sometimes he may be helping us to populate the result or trying to understand the data and all these kind of the things. Whereas machine learning engineers activity is different. Starting from the selection of the algorithm and using all the data pre-processing data pre-processing techniques suggested by the DE, and after that handling of the model, estimation of the accuracy, all these things are the activities of machine learning engineer. And your data scientist is a member who can cope up with all these guys. Okay, data scientist activity is not only look after the SME kind of thing, understanding of the stat-based models, DE activities, DA. That is the reason, guys. Data science is a field where you need to have the knowledge on all these kind of the things. Here and there, okay, you need to suggest something like rather than using this measure, you can go with another measure. Okay, you should have that understanding capabilities and guiding capacities. So that is one thing. And you need to talk with machine learning engineers. Like, guys, so just why you have used this decision tree rather than that, you can go ahead with a random forest. So these kind of the conventions, friends, really helps the team. So because data scientist activities and his subject and his expertise related to the motivation of the or getting work done by the members is always revolving around this data scientist. So the data scientist should know all these kind of things, and he has to integrate all these kind of the activities. It's the job or functionality of the data scientist is not simple, guys. And moreover, he should interact with all the members or various stakeholders. Is a kind of portfolio rather than the project or program. He need to handle the portfolios. Various projects come into the picture, various domains would be there. So your team might be using various kinds of the algorithms, but finally you should be in a position to extract all those, understand all those kind of thing, and guide them in a kind of empowering them. So it is how you can see the automating the automation. Though we are having certain predefined algorithms or predefined data pre-processing technique, but electing for our requirement is the basis for understanding these models. Okay, now a typical definition, guys, because we can start with the definition, but always one important point we have to remember that if we are having the heterogeneous kind of the audience, guys, maybe that is the training or else knowledge transfer or else in the webinars, maybe you are the keynote speaker, maybe you need to talk something about machine learning or data science, maybe 1.5 hour or something. Then in that particular case, setting the context is always important rather than directly opening the PPT and going ahead with the definition. Always setting the context, and before reaching to the definition, you should introduce all the terms and terminologies related to the definition. Okay, that what exactly we are doing now. So as to understand the topic, just we are talking about all the components, and then we are moving to the understanding of actual definition. See here, guys, simple now. ML is an application of AI that provides the system the ability to automatically learn and improve from experience without being explicitly programmed. Without being explicitly programmed in the sense, guys, you may ask this question. Okay, that means every non-programmer is a machine learning engineer. Every non-programmer who is not knowing the programming, because as you are saying, without being explicitly programmed. Friends, here explicitly programmed in the sense, practically you are not writing any logic, guys. That means suppose in a typical programming environment, what exactly the developer does is he is creating some logics. He is applying the logics on numbers or text data, and he is going to get some results. That is what you call the programming. It doesn't mean that always giving the input, fine tuning, observation of the output, hyperparameter tuning. This is not coming into the programming actually. Practically, you are not designing any algorithm. You are just making use of that particular algorithms in your application or to design your model. Okay, so don't feel that okay, this statement is a bit confusing or I need not do any programming. Actually, this is not your programming skill, guys. Based on your as I said, you have to understand what exactly the data, and you have to come up with some kind of the pre-processing techniques, and hyperparameter tuning techniques, and then you should observe that particular model accordingly. You have to specify or estimate some sort of the information related to what exactly you are getting the outcome. Okay, based on that outcome, again going back, fine tune the parameter, again test your algorithm. Definitely, it is going to improve. Okay, because it is all depending on the experience only. It is talking out. Okay, being explicitly programmed, and study of algorithm that improve their performance at some task with experience. See, just if I am having the task and I am giving some algorithm 1, 2, 3. Okay, and we are getting some kind of, again we are revisiting that statement. See, we covered the algorithm performance. Okay, so just we are giving some experience, maybe with a single algorithm or multiple algorithm, we are expecting some performance. Okay, and as if you are changing this your experience, automatically if your performance is also getting changed, and definitely we are going to get better understanding or best performance when compared with the previous run or previous performance. So this is a simplest notion related to the machine learning definition, which is an application that AI. What do you mean by AI, guys? In a simplest terminology, because nowadays everything is a buzzword. Okay, so like artificial intelligence. Many at times, if you see any blogs or any webinar or any meetup, many are there in terms of machine learning, artificial intelligence, and all. Can someone help me? How can I say? Okay, I'm using AI. Okay, AI based washing machines, AI based fridge, and AI based kind of things. So all these kind of the conventions we are talking about. Now, can someone help me in your understanding? What do you mean by artificial intelligence in the simplest terms, guys?
Sir,
Okay.
AI
Ah,
involves using computers to do things that traditionally requires human intelligence.
okay, right. So
Basically,
compute. Go ahead.
basically with the help of computers, make the things
Hmm.
easy which requires in the daily life, as we all depends on the machines.
Okay.
Yes.
Very good. Excellent. Friends, here any act or any process which you are applying to your machines so as to improve the capability, or so as to give some common sense reasoning. Now you see, guys. So as our friend said rightly, any kind of activity you are doing on top of the machine so as to simplify your activity. Okay, because if you are talking about the machines, and if I want to improve the performance of the machine with some sort of the act, maybe through the program, that might be by adding additional chip, that might be by adding additional IoT device, that comes under the category of the artificial intelligence. So artificial intelligence, just we are putting up some kind of the common sense reasoning, and how come the machine is adopting that particular reasoning so as to come up with the result. So the results are based on how you empower the machine, guys, because whatever the act, because there are thousands of acts are there. Some people choose that embedded thing. Some people can select the IoT based. Some people purely depends on the kind of the programming. Okay, because as a machine learning engineer or a data engineer or data scientist, friends, all these kind of the functionalities are making the machines very thoughtful. Now, if you are referencing, Elias says AI makes it possible for machines to learn from experience, adjust to new inputs, and perform human-like tasks. Yes, because we are having plenty of avenues and plenty of opportunities so as to design or so as to handle our working with the machines. So artificial intelligence is a bigger area, guys, actually. So anything maybe that is a deep learning, or neural networks, NLP kind of the techniques. Okay, and then now we are talking about this machine learning. Okay, all these kind of the acts through programming or through algorithms or through hyperparameter tuning technique. In all these kind of the ways, we are doing some sort of the empowering our machines. So that is nothing but the artificial intelligence. It's not a big thing actually. Big thing in the sense. Not in the implementation wise, to understand that particular aspect or to define in a simplest way any act, okay, whatever the activity you are doing, so as to improve the performance of the machine, so as to add some kind of the intelligence to the machine, or so as to improve the common sense reasoning related to the machine, that comes under the category of the artificial intelligence research. So within that particular artificial intelligence, again, we are having the machine learning, deep learning, NLP techniques, neural networks. Okay, like all these particular things are sub branches. So don't get confused between the artificial intelligence, machine learning. What is this technical jargon? Nothing, guys. Compared with other technical areas, understanding of the artificial intelligence, machine learning conceptually is very easy. I can prove that in the today's session, because I am saying that, guys. Big data understanding like Hadoop architecture, Spark architecture, definitely you need to have the solid understanding of the memory orientation and solid understanding of the distributed environment, parallelism, and how the data is moving. That is a different material actually altogether. And all members cannot venture their expertise in terms of big data, Hadoop, Spark, these kind of things, because you should be aware of all the optimizations, memory oriented parallel concepts. But whereas machine learning, if you're having the mindset and if you want to learn, okay, then you can venture within week time or 10 days. Definitely you can get the terminologies and all these kind of the flavors of machine learning. But big data and all definitely requires some at least 3 to 4 months, guys. So as to understand the architecture, so as to perform the programmatical kind of things, all these conventions. And at least now we are having the Spark support, so as to simplify the programmatical constructs of the big data. Otherwise, we need to end up our thinking process related to map reduce orientation, where plenty of code is there. You have to think through all the 4 phases and then convert them into the key value pair, a typical framework actually. But whereas in the machine learning, with the help of the scikit-learn library, okay, we have to thank Python designers, because they provided us everything related to the deep learning, neural networks, NLP, because all these particular libraries are there. And in fact, we'll see some of the flow, okay, how we are performing the activities related to the machine learning implementation. Okay, right. So with this, just we are good to go, guys. Just to land up to impart the understanding of the machine learning and artificial intelligence. Just I have put these kind of the efforts for you now. So in the entire aspect, okay, one important point may be alarming your mind. Without programming, how we can expect the outcome? Okay, now see, guys, here to put those particular things into the image orientation, just your traditional programming is taking the data and program, which is generating the output. Maybe to find out the factorial or prime number or whichever, along with the program, we have to give the data. It all depends on the your input n, and according to that you would have designed some logic. Accordingly, that particular logic is going to generate the outcome. But whereas your machine learning is different, guys. How it is different is suppose you are giving the user data, maybe user log file from the Amazon, and you have given this particular data to your model, and you are getting some outcome. You are getting some outcome. Now, this outcome again you are going to give to your model. Okay, whatever the output you got, output 1, and again you are applying some hyperparameter. Now you are getting outcome 2. Again, this outcome 2 will be given to the model, and you are, this is iterative process, guys. Okay, recursively until your expectation, just what you are doing, this output is a experience actually. And after getting this particular data and as well as the experience, it becomes a program because itself it is revising that. Okay, revising in the sense it is trying to understand the insights of the data. Okay, it is establishing some kind of the learning, and it is observing all the patterns which are there in the data. Okay, after that, just it is providing us some sort of the prediction. So based on that particular prediction, again, if you are happy with that particular prediction, if our subject matter expert, statistician, all the team members are okay to go ahead with that particular accuracy, then you are done. Otherwise, again, you need to go back and fine tune these kind of things. Especially guys, this is what you call the backward propagation. Even in our case also, guys, let me put in this a case study kind of thing. Let us assume that we are writing an article. Okay, maybe just I thought of giving some kind of article to you, a research paper, where that is embedding all the adaptive query execution, all those kind of the conventions. Now we are a team of members, and we are ready with our first draft of the research article. Initially, what we'll do is we'll circulate that article to our company members who are having inclination of understanding the machine learning and suggesting something, so that in the first run we are getting some feedback. Okay, maybe this is very good, but how Indium is using artificial intelligence and machine learning, if you could add that point, then we'll be very happy. That is one sort of the suggestion. Now you can post that particular thing in the LinkedIn. LinkedIn, is a kind of place where you can get more like-minded and more intellectual kind of the platform, so that they also maybe from UGC or AICT or some different universities, academicians, and even practitioners, and from all these different genres we may get the feedback. So first feedback we have embedded, and we re-released that version 2, and that particular version 2 we have placed in the LinkedIn platform. Now at the moment, guys, after placing that particular article in your LinkedIn, then automatically you will be getting some suggestion. Can you focus on this thing? We need to understand this point. Maybe I'm denying this aspect. So based on your discretions, again, you can come up with the second version. And thereafter, maybe you can ask some members from the universities, maybe university professors or whoever. So just we can put across, and finally you can publish the article. See what we have done, what we are doing here, guys. First we are proposed our idea, and we shared in our company, and we got some kind of the suggestions, and then we placed in the LinkedIn platform, and then we got some feedback, and we have embedded, and then we are going to submit our revised article to the appropriate chair. So like that, the machine learning also, it's not a single phased learning, guys. We are not publishing, or we are not submitting our article directly to the journal or directly to the kind of the conference. Rather, we are submitting that thing to the revision process, and we are getting some sort of the suggestions for the betterment, and we are embedding all those kind of aspects, and finally we are landing that particular research to the final version. So here the point is, guys, how a human being strive for the betterment with his experience, and by talking with all the other members, putting across his ideas, maybe getting the suggestions or feedback, again incorporating all the feasible kind of the feedbacks. Okay, and again coming up with the latest version. Similarly, here also the machine learning, what it performs exactly is we're having some solid data, and after inquiring or after pre-processing that particular data, and our algorithm turns that data into the model. That model is here the program, and that particular program definitely gives some kind of the metrics. I'll give you the entire life cycle, guys, in a while, so that you can clearly connect the dots without any problem. Once you generate that particular model, if that model is not up to your expectations, again what you do is just you give the same model to the machine, by adding some more parameters or by fine tuning the kind of the data pre-processing, whichever. So now the same kind of the model, again a revised version will be taken by the machine and it is re-execute the appropriate model and it is sending us the outcome. Again, that outcome is not satisfactory. Then you have to see that whether there is any problem with the data or any missing values are there. And we are not changing the data, guys. Just observe that changing the data is never allowed in the machine learning or big data kind of the scenarios. Don't touch the data. We have to fine tune and we have to pre-process the data. That is what manipulations are not allowed. Only the thing is whatever the data we are having, we have to understand that particular data. Maybe buying habits of the people or sentiment analysis, all these predictions of the diseases. You are not going to modify anything. Only the thing is you need to provide a technique for the sake of handling the missing values or handling the, scaling the data. Okay, without loss of the generality, without touch basing on the original data, you can encode that particular data into some other numbers or something like that. Okay, so this is how you can see, how you can observe uh, after each run. Your system is generating some sort of the model and based on that particular model we are getting some sort of the outcome. So this is how you can see a bigger analogy related to the traditional programming and as well as the machine learning program. In the traditional programming, guys, just we are giving the data and as well as the program, so solid output we are getting. There is no fine tuning or something like that. Maybe you can work with the algorithm like to change the space requirements or to reduce the time requirements. Fine tuning is there in the normal programming also in terms of algorithm analysis. Okay, time space trade off like that. But in this case, though we are focusing on those basic points of time and space, but apart from that, our intention is our intention is so as to handle this particular outcome, whatever we have got from the running of that particular algorithm, and how we are making use of these particular outcomes in a better way by adding our expertise in terms of data pre-processing, in terms of feature engineering, in terms of hyperparameter tuning technique, and in terms of changing the algorithm itself. Sometimes, maybe we feel that support vector machine is good for implementing the algorithm. Maybe later we realize that the support vector machine is not doing well. So in that case, we can go ahead with the naive Bayes or decision tree or k nearest neighborhood like that. So these kind of the common sense reasoning we are going to adopt, and actually we are empowering the machines, guys, and machines with our proper inputs, they are going to generate the corresponding outcomes in terms of predictions, accuracy, true positive, true negatives, all those kind of the conventions. And of course, after completion of the algorithmic understanding, just what I will do is I'll give you some kind of metrics also so that you can also confirm that how these metrics are really helping the developer to understand or machine learning practitioner so as to keenly observe what's going on and what exactly the data is trying to say and how we are maintain the activities. And one more important thing, guys. So this thing can be done by any machine learning practitioners and all those kind of the members. But whereas if I'm talking about the expertise and you have to keenly observe the data, and apart from that particular kind of the conventions, the most important part is how we are conveying and how we are interpreting your data and how you are explaining your findings to through the client mechanism, because clientally most probably the functional users and they may not know the technicalities or stat or maths behind our algorithm, but with the numbers, with the observations, you need to convince them like these are all the areas you have to focus, because after getting some kind of the outcome, you should leverage that particular outcome. Suppose 98% accuracy you got. Then if you are saying 98% accuracy in front of the client, then what is the use in terms of my business, in terms of my client, I mean, in terms of my customer, how do I reach them more? Is there any hidden pattern is there where which definitely helps me so as to get into the observation? Or can I use which are all the pillars or which are all the points I need to use related to the convention? So these are all very going to get the information and where you are going to give the information towards to the members. Okay, that is what where your efficiency comes into the picture. Like not the selection of the algorithm, or of course that is also required some kind of so that fast in an immediate basis you can elect the algorithms and you can perform the tasks. Now moving ahead. So just if you are considering related to the applications, whenever there is a data, there is an opportunity to use that particular data and analyze that data. So if I'm having, suppose I can give you a simple example. Maybe latest release is there. Okay, so every Fridays, Friday we are getting new movies. And first nowadays, the movies are not doing really well. First, I want to check with my friend whether that movie is really good or not. And he is knowing me and he knows my favorites. So that I asked him, assume that 2 or 3 members I asked him. Then they said, okay, movie is good and based on your thing, okay, you can enjoy that movie. And maybe there is a biased kind of the thing also, guys. Like, maybe there is a conflict between me and my friends. They have planned for a trip, but due to my laziness, I could not turn up. I have switched off my phone and I am not reachable to them. And I denied all the calls also. Okay. So just I want to take rest and I want to study or something like that. Now the point is that point happened before 1 month or something, but still my friends are angry on me. So in that case, they suggest me such a worst movie, and at the end of the day, I definitely feel bad. Okay, see, after viewing that movie, my mood got changed, or everything. So there is a biased kind of thing, guys. If I'm taking opinions of less members or maybe 2 or 3 members, maybe correct also sometimes, but that may there are more chances to end up with some sort of ambiguous or biased kind of the situation where if you see the book my show reviews or Google reviews, even though if you are able to work with some sort of the client and some IKEA, Uber, all these kind of the clients of India, so just definitely we'll see okay how that client is. Okay, whether he's a task master or how we are getting the appraisals and whether he's really promoting us or not. All these kind of things, some kind of glass door, all these kind of the reviews we'll go and see. So which will give some kind of the understanding without any bias. If I want to get something, definitely I should have some more data. Okay, based on that particular data only, there is an opportunity of learning and understanding the patterns. So the point here is, guys, just we need to have the data, understanding of the sentiments of the people, and then based on that particular convention, you can come up with the patterns, which are all the patterns, which are all the specifications available. Okay, now we are making some sort of connect with our real machine learning, because up to this, guys, if you are not having the mindset of okay, it's not a magic or it's not something like a kind of god to understand, not like that, friends. It is purely your how can I say, your habituation and how you train your mind to understand the machine learning aspect. Because if you see some of the movies, you need not think through. Just the movies, some Manratnam movie like that. Okay, just it is going simple. Whereas if it is some sort of all the technicalities, okay, all we need to understand some high end okay, all the technical aspects, then we have to think through why it is so happened. Okay, so all these kind of the things you need to present your mind there. And if you miss out any one shot in the screenplay of the director, okay, so Cameroon, all these kind of the directors, definitely there are certain misconceptions. I mean, misconnects. Okay, we cannot connect the dots if you miss out a single scene. So your attention is most important. So what I'm saying here is machine learning is also based on your detailed thing, guys. It's not a big programmatical aspect, and it is not very nearest to the programmers. I cannot say that. Your efficiency and your habituation of understanding the algorithms, because definitely I'm saying machine learning is not tough. Definitely understanding of the algorithms, but only the point is you should not avoid the statistical background of that. However, I'm floating one more course on this machine learning with statistical aspect for each and every algorithm, because definitely 10 to 15 algorithms we are going to use in our projects. Okay, or you would have used in your project, some of the people maybe. So the entire aspects are revolving around these 10 to 15 algorithms most of the cases. So what you can do is if you could able to understand these particular algorithmic notations in a solid orientation, then you're done, guys. Okay, you need not worry about the expertise and all. Expertise automatically comes. Okay, if you understand the insight, and if you are able to perform the aspects according to the algorithm, and if you are okay with the statistical background of that particular algorithm, then you are done. Okay, but without having that statistical understanding, just if you are studying the algorithm and you are implementing, maybe the complete circle of learning won't complete, guys. Okay, that is only the point. Definitely but this course only focusing on the Spark orientation of the Databricks certification, and apart from that, both D and ML topics we are covering, but still the span of this course is scope of this course is not enough to cover the complete statistical methods and machine learnings. Okay, so that definitely we'll see in other course without fail. Now let us try to understand. Now what we have confirmed is based on your data, we are having some kind of the opportunity of understanding the patterns and hidden knowledge of that particular data. But now how to start? Because okay, I'm committed to machine learning and I want to learn ML, and I want to apply machine learning kind of the algorithms in my projects. Now what is the type of that particular thing? Because you are saying learning is something like where human expertise is not enough, where humans cannot explain the things, where humans are unable to observe the patterns practically. Now what is the state and how do I reach that? But in what way I can achieve these kind of the conventions? Yes. Now there are four different kinds of aspects, guys, actually, where the entire machine learning is talking on these four liners only, guys. Either your algorithm should belong to the supervised, or else that should belong to the unsupervised, or else semi-supervised, or reinforcement learning. Okay, these four are various types of machine learning categories where you can observe, where you can identify some sort of observation related to the machine learning types. And what do you mean by supervision? A typical student master relationship, guys. Like so master, so just instruct the student. Okay, these are all the topics you need to study, and these are all the presentations you have to make, and you should present. Is a handhold kind of the teaching. That means the training data include desired outputs. Specifically, if you ask me what is the outcome of this training, empowering you in terms of the Spark along with the Databricks certification. Okay, so that is the outcome. So if I could able to say the desired outcome, then that is the supervised learning. Training the data includes the desired outcome. So just I am very clear about what exactly the outcome while implementing the algorithm or while starting with some kind of the project. So those kind of the things are comes under the category of the supervised learning. Now, if you see the unsupervised, guys, training data doesn't include desired outcomes. This is something like, let me put in this way. Suppose we are talking about the Amazon market basket analysis. Okay, and this particular market basket analysis has given some sort of the data to us. the data is containing customer name, customer address, income range, his yearly purchases. Okay, now what we have done is, guys, just we have observed the customer behavior, whereas these customers are having some sort of the income and their yearly spendings, their yearly spendings. Now here just I'm having some $1,000, $2,000, $5,000, and maybe 10,000 I can put, because in US okay, more expenses would be there. And then I'm having $75,000, something like that. And his spendings are maybe 100, 200, 300, 500, assume that $500. So now there are certain situations where we got some people of similar cases. Okay, this is group one. These guys are okay. These guys are group two, group three, group four, group five. Now see, guys, can someone comment on group one, group two, group three? Because we are targeting the members in such a way that so we are launching a new products and we want to convey that information to our customers in such a way that okay, we are going to launch this particular product, friends. As you are a premier customer, we want to offer you this much discount, or along with this particular thing, we are having the gift pack. So we need to shortlist the customer information, and to those customers only we need to send the messages or mails. Now that is the idea, guys. Actually, we got the data and we are having complete idea about our customers, what is their income range and what is their yearly spend. Now tell me friends, okay, or else let me put this question in direct way. Who are all the customer groups I need to target? Whether G1, G2, G3 or G4, G5.
G1, G2, G3, sir.
Monu, why it is so?
Because of yearly expenses.
See, Monu, here the problem is these guys are earning less, but spending more. These guys are earning less, spending more.
Yes.
If you are again, as a data scientist, again you are killing them, na? Their problem, their family will bankrupt. Okay, see the situation. That is what, friends, machine learning or data science is not only technicality, but you have to see that the other way around. Now you think through, now you can get the answer. Now you can get the answer. You see these guys, they are like Ambani and Adani. They are not spending much. Maybe they don't know the products which we are offering. Maybe they don't know even they are having the potential of buying, but they are not buying the things. So that if you could concentrate on these two groups, because they are getting high income, okay, they are in the high income range, guys, but they are not spending more yearly. So first target is these guys, G4 and G5. And G2 somewhat okay, guys, because medium range sal, mid range sal, of course we can focus. But if you are these guys also low spend and low income and low spending, that is also fine. Okay, no problem. You need not touch base on that. They are on track. But these guys don't touch, because if you touch these G3, they will be in trouble. Their family will be trouble. So these insights also you need to focus, guys, because marketing is something like yeah, at the end of the day, we are all humans. That's all. No data science, no machine learning, nothing. We have to serve our family. We have to see our welfare also. And buying habits, all those kind of the conventions, of course, required in life, but not at the matter of our peace and not at the matter of our expenses, not at the matter of our EMIs. So a wise, and of course, turning up is also important, guys. Suppose if I'm reaching to some thousand or so, I need to spend for each customer, I need to spend $1. Assume that if I am spending $1,000, I am only getting 10 members as the outcome, which is a failure model, Rather, what I can do is at least 25% of the members should be turned. So that means 250 member. So you are sending 1,000 mails, no problem. $1,000 has been spent already. But with these 250 members turn up, I can make more money. So that is the strategy, because maybe you need to think in terms of the business mind while performing the sentiment analysis. Maybe in terms of if you are doing some kind of the medical image analysis or something, you should turn as a doctor. Whereas if you are making some kind of the projects for the universities, you should turn as an academician, at least for that particular moment. So the mindset and the orientation, how we are exploiting the results is all important, guys. So here practically there is no outcome. If you see this diagram, what I am saying. So in the second way, guys, unsupervised training does not include desired outputs. It is you to decide, because your the manager or else the appropriate financial head come to you and let me know which are all the groups I need to raise the a mail. I have to shoot out the mail to these set of the people. Let me know whether I need to send out of these 5 groups to which group I need to send the mails. Then you should say that G4, G5. Next question is why. He may ask, because he's a financial head, na? Definitely greater than us. So whoever handling the finance, they are more intelligent than all of us guys in the earth. Okay, whoever handling the finance, no matter whether your PhD, your skill, your domain knowledge, your scientist, nothing else. Financial heads are the intelligent people because they have to spend intelligently. Even in our house also, if you see your mother is a financial head. Okay, so she knows how to spend and how to handle. So likewise, guys, now you have to convince him. Why I need to send mails to G4, G5? Why you are excluding G1, G2, G3 people? Now you should able to tell logically, yes, the problem here is the finding here is G4, G5 guys are in the high income pattern and they are earning more, but they are not buying our products. They are not high yearly spending customers. So that if you could able to share our products information, or if you target them, definitely, because they are having the buying potential, buying capability. So in a way, they can make use of our products. Okay, and so that we can increase our business also. So likewise, guys, here, all these kind of the conventions can be observed. Practically, there is a groups actually. There are similar kind of the item. There are no specific outcome, guys. Like in the earlier example I have given, like training includes desired outputs. Maybe that is housing prices, or if the student studies for 8 hours, whether he is going to crack the IIT JEE or not. These kind of the things are supervised because we are having the desired outcome. Whereas here it is purely your understanding, your capability. That is what, friends. While dealing with the unsupervised learning, be cautious. Be cautious. Reason is there is no outcome. It is all you people to decide on what basis you need to hunt the people, or on what basis you need to explain your finding outs. But whereas in the first case, it is pretty simple. It is all your talent to disseminate the results to various kind of the customers or members. And after getting that particular data, just you are going to get the appropriate output, and existing output is there, and you can compare that one with the generated output by the model, and you can say that okay, this model has done this much good, so that we are happy with the findings. This is what how you can refer the supervised and as well as the unsupervised. But most importantly, the unsupervised learning, your understanding, your capabilities, your involvement is more. Okay, your involvement is more required, because supervised is a fine tuning. Results are also we are pretty know that what are all the results we are expecting, and we are very clear about the outcome. But unsupervised is not like that, guys. Okay, just we are getting some kind of the patterns of the data, or we are getting some set of the uh, common data items. Based on that particular thing, you need to decide whether I should go with this kind of the approach or what. Now, there are certain situations, guys, where you want to purchase some product, but very less amount of the very less, I mean, very nominal reviews are there. Okay, for that particular purpose, you can go ahead with the semi-supervised. Especially, guys, if you consider the Zomato or Swiggy, there will be getting after clicking on that particular menu, and they suggest some kind of the restaurants for us, some kind of the to order the food. Again, if you click on that, itemized reviews would be there. Okay, maybe if you are asking for a particular food, okay, so then if you are based on that particular food item, so just you need to maintain the convention. Like very few reviews are there, but they are saying bestseller. Okay, the app is saying bestseller, but reviews are very less. Now the another food item you selected, that is not really the bestseller, but review says that okay, this food is, because maybe 5 or 6 reviews are there, all 6 reviews are good. Now in this kind of the situation, guys, we are we are not having the enough input data. Okay, we are not having the enough input data, and with that input data only we need to conclude the decisions. That is what you call the semi supervised learning. Okay, maybe sometimes you would have heard about semi is in between supervised and unsupervised. Don't get confused, guys. Semi supervised in the sense it is also belonging to the category of the supervised. See, the thing is, training data includes the few desired outputs. Yes, definitely the same kind of the definition for the semi supervised, but only the differentiation is if you are having very less number of the inputs. Okay, your inputs are very less, and that means data set is having limited number of the records. Friends, as I said, what is the problem with the limited number of the records? What is the problem with the limited number of the records? Bias. Okay, only if you are going by 1 or 2 decisions, you may not get the actual essence of the corresponding review. Whereas if I'm having some hundreds of the reviews, so that I can segregate them. Okay, so and I can see how many positives are there, how many negatives are there. Then if number of positives are far ahead compared with the negatives, then I can take the decision. Whereas if number of negatives are far more than positives, then we can reject that particular product. But the case is distinct here, guys. And of course, your Ola, Uber, Zomato, Swiggy, all these kind of the apps. Okay, earlier we are having that websites, guys. Now we don't have any website. Definitely we have to launch the appropriate app, and through app only we are going to book the vehicle. Reason is they need to track our I mean location, and they should contact us. Okay, because that immediate action is required. But in the machine, if you are booking the things or else schedule the appropriate aspect, tracking is very difficult. So for that particular purpose, just we are making use the convention of these semi-supervised, especially in the app engineering kind of the sector. Maybe if at all you need to work with those kind of the people, whereas your input data is very less in numbers, then in that particular case also you want to perform, then those kind of the categories are known as the semi-supervised. Okay, with less amount of the data, and especially, guys, logistic regression is very good to handle these kind of the cases, because some of the algorithms are performing very well if you give huge amounts of the data. With the heavy data, it is easy for algorithm so as to come up with some kind of the outcome. Whereas even for the nominal or little inputs also, your logistic regression is really doing well. Okay, in that particular case, if at all you want to make use of the semi-supervised kind of the things. Now in the gaming, friends, actually maybe in chess or in some kind of the gamings, while playing some Ludo or those kind of the games, guys, after achieving some success, we'll be getting some reward points. Okay, So in mobile games also, just if you are playing, they will be giving some 100 or 200, some reward kind of the thing. So if you are selecting a particular path, if that path is correct, then we'll be getting the reward. Otherwise, if that particular path is not correct, okay, you won't get anything. Maybe in fact, they can reduce our rewards also. So the point here, guys, just in what way you are making use of the paths or moves, and if the path is correct, if you are moving in a right direction, it will be rewarded. And then and there you can feel that, oh, I'm going in a proper direction, then it is good for all. So this is how you can manage the convention of handling the machine learning kind of the thing: supervised, unsupervised, semi-supervised, reinforcement learning. Supervised, your training data include desired outputs. Unsupervised doesn't include desired outputs. Semi-supervised, inputs are very limited, but with that particular inputs only you are going to analyze the data. Reinforcement learning, it is purely reward based, especially the appropriate aspects, guys, where we are making use of the convention, like how I am getting the data and how to conclude that particular understanding. So this is how you specify the orientation of supervised, unsupervised, semi-supervised, and reinforcement. Now let us jump into the algorithmic understanding, guys. Okay, I have compiled something for us so that we can have a look on these kind of the conventions and we can move ahead. Okay, up to now, any doubts, guys? Please paste in the chat window so that we can have a look on that. Okay. So now you observe, guys, here this point. Okay, everything goes well up to here. Okay, we are very much excited. Now we can start our journey of the machine learning. Straight away I can pick up the data and I can apply the algorithms, and within 2 or 3 days I become machine learning engineer or data scientist. Hold on, guys. Because here is the challenge, because generally, uh, machine learning journey needs some kind of the attention. Like, there are certain challenges actually. There are certain challenges, and every day, machine learning engineer or data scientist should keep these points in the mind without fail. Because, guys, it's not a highway ride. Definitely, there are many obstacles where the machine learning engineer or data scientist need to look after or look up into these kind of the aspects. The very first thing is data comes in all shapes and sizes. Your data is not fine tuned, guys. Maybe nowadays, if you see the Twitter, if I want to perform some Twitter analytics, or if I want to perform some Amazon log file market basket analysis, in that particular case, guys, your data, your customers, maybe with smiley, they would have responded. Maybe with thumb, they would have responded, or maybe some sort of images, some sort of the videos or podcast. Okay, your data may be having audio or video kind of the thing. All these kind of the conventions, maybe stars. Okay, nowadays we are seeing the star-based reviews also. So to analyze this particular data, to understand this particular data is a real challenge. That means data is not always the text yes or no kind of thing, or true or false kind of thing. Rather, it is you to convert or to understand this particular data and encode this particular data. But don't worry, we are having certain techniques, guys, where though we are getting the data in all shapes and sizes, we can fine tune them and we can come up with some kind of the analogy. Second important thing is most dangerous thing: pre-processing and dimensionality reduction. Assume that, guys, we downloaded some log file. It is containing some thousand features. Records may be billion records also. Don't worry, guys. And as many records we are having, you can have fun as much, because with the 100 records, 1,000 records, you won't get the real insight. You need not bother about the number of records. Only our problem is only our problem is number of columns, number of features. Because, guys, features decide our machine learning algorithm fate and our models efficiency. Suppose you are focusing on Nowadays, guys, in the companies also we are getting some psychometric test. The test is something like that. Maybe we are shortlisting some of the members for the leadership position. Assume that in that particular case, we need to give some scenarios, and based on the scenarios, how these people are responding back. Uh, maybe maybe referral bonus, or that might be okay, referring your neighbors, or referring your family members. Many things would be there. Now maybe you can say, if I know that person as a friend, I am referring, why can't I refer my family member? So that kind of the mindset would be there. So always that may not be the situation in the company's perspective. Companies, if your family member, you are referring to our company, maybe your family member at the end of 6 months or 9 months, maybe directly or indirectly reporting to you, or maybe comes under your purview, then there are some kind of the biased decisions or some favorisms or something like that. So these kind of the analysis, okay, these kind of the things are involved in the data capturing. Okay, so directly it may not reflect. You may think that, okay, I can easily defend if my manager asks also, I can say he's my family member, maybe my cousin, so that I know him from childhood, so that I can strongly say he's committed like that. But you can defend in all the ways. But with that simple act, people may estimate you, because not people, actually the application itself, the psychometric analysis says that in majority of the time he has shown his personal interest rather than the professionalism. And with that single statement, okay, you are we are not going to get anything, any negative or something, but definitely one form of impression would be there, na? So just to observe, guys, like in terms of features, okay, whatever the input data I am taking, and some data items or some features may be negatively contributing also, and some may be positively contribute to our analysis. Some may not be doing anything, neutral. If you are placing them or not placing them, zero. Sometimes, you place that feature, it may degrade or decrease the accuracy level. Or if you place some of the features, it increases the accuracy level. So based on your discretion, based on the observation, of course, we're having some techniques for that, and to see the variable importance plot and all these kind of the conventions you can perform. So dimensionality reduction, curse of dimension is there, guys, because curse of dimension is something like where your dimensions are killing the appropriate efficiency of the program or observation. So be cautious with the dimensions, and of course number of records. If it is more, we are more than happy, because as we are having number of record, definitely the analysis also perfect. Whereas if I am saying my features are 1,000, then we have to fine tune those particular features, and we have to break those particular features, and apply some kind of the mechanisms where to filter out which are all the features really adding the value to our model. Okay, this is how you can see the challenge in terms of implementation, guys. And next and third important point is identification of the best model and hyperparameter tuning technique. Friends, here most commonly used term is hyperparameter tuning. And moreover, hyperparameter is not directly available, guys. Maybe if you are studying some kind of the algorithm, and that algorithm may be having some 10 to 15 parameters, assume that 10 to 15 parameters. And out of those particular 10 to 15 parameters, some of the default parameters, some are the optional parameters, some are the mandatory parameters. So now, with the help of optional parameters, there are sometimes, you can improve the performance of the model. So the hyperparameter tuning is something like just to pull those kind of the parameters in the algorithm, and accordingly you can fine tune the appropriate aspect. After tuning your parameters related to that algorithm, then definitely you can reflect the things into the model. Now you may be thinking, what is this algorithm and what do you mean by model? I'm coming to that point, guys. Algorithm is a baseliner, which is a base technique. As I said, naive Bayes, support vector machine, k nearest neighborhood, decision tree, random forest, all these kind of the things are there in terms of the algorithm. Your model is nothing but you have to submit your data to the algorithm, and you have to observe, you have to apply some data pre-processing technique, and you need to identify whether your algorithm is properly fit or not, and prediction. All these particular things are nothing but the model. Okay, your model is the combination of the input data, data pre-processing, algorithm. If you are adding these three, it becomes the model. But algorithm is plainly which kind of the algorithm you are using. That is a predefined thing. Whereas to this predefined thing, if you are adding your data set, if you are applying some data pre-processing kind of the aspect, then that becomes your model. So this is what how you can handle the usage of the model and as well as the hyperparameter tuning in terms of the algorithms. Okay. Right. So data comes in all shapes and sizes. We have to fine tune that number of dimensions, causing some kind of the complexity in our machine learning implementations. We have to manage that particular convention. Next important thing is best model and hyperparameter tuning. Now what I will do is guys, just let me share some kind of information with you where you can see how we are performing, because we are talking many things, but at the outset, how we are going to implement these kind of thing. You may feel that, okay, do I need to learn everything in the programming, and what is the I mean, how do I manage the conventions, all these things. Okay, here I am showing you some sort of naive Bayes algorithm. Don't worry about this. I'll give the insight of this thing. But I want to give you some sort of implementation. As I said, now this is the statistical methodology behind that naive Bayes kind of the algorithm, and thereafter we are having some parameters related to the naive Bayes, Gaussian, Bernoulli, multinomial, like that. And here, in what way we are going to perform the implementation of the algorithms. Now you see, guys, the very first step is, of course, before this particular first step, all the discussions and selection of the algorithms, and how do I and what I need to perform the logic, all these things will be same, will be there. But we are talking about the implementation perspective. You may feel that, okay, we have discussed so many things, but how do I manage these kind of the conventions related to the approach? So in that particular case, guys, just we need to import the libraries, because if you consider, especially if I am making use of machine learning algorithms or deep learning or NLP kind of the techniques, there should be some solid support of the packages, especially if I am talking about the machine learning algorithms, especially if I am talking about the Python. Scikit-learn is such a repository, such a treasure we are having. You can explore more and more related to this scikit-learn, guys. Now we are importing, basically NumPy, and as well as the pandas, all these kind of the matplotlib. And just we are making use of the import statement by reading this particular data. Now, if you consider, so exploring of the data. So just if you are making use of these kind of the conventions, guys, exploring of the data is something like whatever the information we are having, just we are making use of that particular convention. Don't worry, guys, just it is not responding. What I will do is naive Bayes implementation. So because they sensed that, that is what how you can understand the artificial intelligence. Okay, they simply stopped as machine learning mastery, not these two words, data science. Yes, Kaggle. This is a standard practice, guys, where that's what I insist while reading, though some kind of the blogs are very tough, just to see the others also. Either you see the company they are working or else their academic credentials, guys. Okay, because there are certain chances where you can observe the notion of, okay, how they are implementing and what they are performing the things. Okay. Uh, let us wait. So because I want to show you what is the kind of the programming we can manage with respect to these things. Okay, naive Bayes, same thing. And now see guys here how we are performing the act of understanding this thing. Okay, so just is a typical importing of the libraries where we are importing some NumPy, Pandas, Matplotlib. Generally, we habituate to make use of that Python based kind of the thing. And up to this, we generally apply in our typical Python orientation also. This is also not a machine learning based. It is we are guiding our notebook. So we are picking up the data from somewhere. Just we are giving the directory name and file name, and without any hassle. Because at the time of getting your AWS kind of the Jupyter notebook, you may not have access of the local file system or something like that. Your local directory. So in that case, it is always preferable to automate that. Whenever you are getting that particular data, automatically your notebook should point to that thing. Now warnings, guys, just it is a general practice for the developers. See, the point is pretty simple. Open sources are having some challenges, guys. Like they are deprecating something and they are adding some more things, and some of the functionalities may be under monitoring by the research team. So they will give all these kind of the messages to us. So if I don't want to get all those kind of the messages, these things. Now importing of the data set, it is a typical reading of the CSV file. Okay, and if you see, this is the data frame actually. Just we are reading that particular data. Now, most importantly, this is the point where we were talking about your data pre-processing and exploratory data analysis. Exploratory data analysis EDA, what it does is just it is exploring the data. Suppose if I am asking you, if I'm giving some document, and I may ask you, right, friends, can you study this document? Can you explore this? And can you summarize on that particular point to me? So these particular things, okay, because data is practically even I am seeing also I cannot get all the things because it is some sort of numbers or text data, all these things. And individually, if I'm picking a record, it takes years together to complete those many records. So we need to have some solid preparation to understand the data in the evidential manner. That is what you call your exploratory data analysis. Now we are seeing the how many rows and columns are there, and just we are observing the top five elements, and then we are renaming the column according to our requirement, and thereafter just we are again seeing the data, what exactly the things, and summary. Actually, friend, the beauty of this Python language is without much efforts, like without much programming. That is what the reason, starting from the generic programming up to the web development, deployment, database programming, and then we are running through the data engineering phases and data science kind of thing. Not only complete Python orientation, guys, even in Spark also you can make use of the PySpark based coding. And even if you are referencing the Hadoop based kind of the environment, with the help of the Python code, you can implement the MapReduce orientation. Okay, so everywhere, all these kind of the conventions are there, and you can make use of these aspects related to our Python. So just if we are considering the info, it is giving all the information, how many entries are there and how many nulls are there, how many non-nulls are there, all these kind of the things. And if any nulls are there, then you have to decide how do I handle that nulls. That is a concept called missing value imputation. So basically, before applying any of the concept, first I should see that what exactly that record is trying to say to me, because understanding of the data, understanding of the corresponding information is most important. Data always trying to say something for us. Okay, so just if I am making some statement, maybe you are giving some presentation, guys. So within the 5 to 10 minutes presentation, how do I estimate your confidence levels, your way of exhibiting, and how you have designed your presentation, and how much time you have spent, and where exactly you are pausing, where exactly you are excellent, all these things within 10 minutes I can see now. Like as a mentor with this much of experience, with these qualifications, definitely I can apply my experience to gauze you. Okay, so just if you are referencing these kind of the packages or these kind of the methods helps us in through the single liner, you can able to understand what exactly the existing contents and all these kind of the conventions. Now see categorical variables. Categorical guys like blood groups and as well as male or female, all these qualifications, all these things. Okay, like qualification, though it is categorical, it is having some level actually. Maybe BTech, MTech and PhD, there is a level. And even movie ratings also categorical, but still there are ordinal. Okay, there is some order internal. But whereas blood groups, all blood groups are same, male, female equal. So those kind of the things are comes under the category of the categorical. Now there is a chance of working with the categorical, and what I want to do is I want to convert those categorical data into the numbers, because rather than these education, marital status, occupation, race, all these things as it is the process, if I could able to convert them into a common range, then 1 0 yes or no kind of thing, then I can perform the appropriate analysis easily. And then thereafter the missing value friends, actually if you see the SQL kind of thing is a null kind of value. Okay, null value, if you are adding with something, entire value become null. There is a dangerous aspect with null guys. And moreover, if you are not handling null values, it is having great impact on our predictions also. So definitely we have to maintain that convention along with the categorical data. We should manage that missing values also. So see the flow of the program guys. As of now, all are your typical programming conventions only. There is no separate aspect. But let me jump into the machine learning terminology. Once that is over, okay, just all these things are common, exploratory and understanding of the data up to this as usual. And he still the developer is exploring the content. Now, this is also the typical understanding of the data. They have not yet started the implementation. This is the missing value imputation, of course, comes under the category of the data pre-processing, all these data pre-processing kind of aspects. Now, yes. Okay, split the data into training and actually your machine learning task start from this step only guys, not from the loading of the data, not from the exploratory data analysis. And to be frank guys, data engineer functionality is that loading, importing of the libraries, pre-processing in terms of missing value, encoding, handling of the categorical data. Up to that data engineer's scope is there. And of course, guys, from this point onwards, once you get the data, once you are happy with the appropriate outcome given by the data engineers, now you can apply your thought process, or now you can apply your understanding on top of this particular data. And however, I'll come to this point, guys. What is the training and testing set? Because that is the most important point I need to discuss in the life cycle of the data science. But just observe that, guys, how we are performing the logic. As I said earlier, there is a package called scikit-learn. From this, I'm having that model selection module, and we are importing train test split. So just if you observe, guys, suppose if I'm having 100 records and I'm separating those records into 70 and 30, and 70 records I'm using for the training phase, remaining 30 I'm using for the testing phase. This is something like this. Suppose I want to check my efficiency of the algorithm. Check my efficiency of the algorithm in the sense it is like this, guys. So we are giving some Udemy access to the members, and we are giving trainings to the members, and even we are planning to give some functional training to the members, emotional intelligence and how to behave, and how to become a kind of managing managerial kind of the techniques, all these things. So whether you are committed to complete half an hour video watching in the Udemy, and whether you are attentive in my session or not, whether you are functionally doing well or not. That means self-learning. Second important thing is if the trainer is teaching, whether you are responding back to the implementations or not, that is the second observation. Third observation is functional. Okay, if I'm giving some presentations, whether you are attempting or not, whether you are absenting. So just okay, if you are not interested to give the presentation, then you are not fit for the leadership, or you are not fit for the appraisal. You are not fit for the promotions or something. Maybe this is a simple thing in front of you or in the mind of you. But what we observe is, guys, how you are responding to the uh, implementations, or how whether you are feeling responsibility to guide someone. Because after all, to give the presentation, you are hesitating, you are not accepting to present something on whatever you have learnt, then how we believe you to give a kind of responsibilities to lead the team or something? Just to think through, guys. So everything is having some connect. Don't feel that we are independently running and we are independently taking the session and observing you. No, not like that. Apart from the trainings, so many outcomes I can guess from you guys. We are applying some unsupervised learning here. Okay, maybe based on your observation, just I can say, okay, this guy is good, and this guy may not be suitable because he never turned up to my queries in my session, and he never turned up to give presentations. Then we cannot believe him like that. Maybe my perspective only. Maybe one parameter if they consider also, you are unnecessary on the loose ends. Why you leave the loose ends? Connect the dots and prove yourself, guys. That's what I'm saying. So here, why I'm talking these things is some sort of the data should be there where I need to prove myself. These things are my model is correct, because while giving the presentation, I am recording everything, and orally I'm saying some feedback to you, but a written feedback I'll be sharing with your managers. So what we are doing and how we are performing. Okay. So, and of course, operational team is sending the absentees list and all these things. That is a different thing. But my observation is technical, and how we are functionally doing in the session, and how we are responding to the technical aspects and all. Okay. Now the thing is, why you are keeping these data is so as to cross check. Okay, in the team how he is behaving, and in the trainings how he is behaving, whether really this is mapping or not. In reality also, guys, 70% of the data used for the implementation of the model, your 30% data is there. Na? That 30% data can be utilized for that 30% data can be utilized for whether your findings are correct or not. Maybe your model is saying something, and I'm giving some new data altogether. Okay, I'm training you, and I'm in fact testing you on Friday. Maybe 3 hour exam I am going to put. Like, I'll be sharing the appropriate question paper with Deepika. Deepika may be releasing the question paper by 9:55. Just you need to take the exam. Okay, not proctored, guys. Definitely, I'm having belief on you. So 3 hours just to sit and complete, and then you upload the same. I will share the placeholder also. So that 3 hour exam, what we see is whatever the learnings I have given, whatever the training I have given, apart from those kind of thing, I will give some application oriented. Okay, some kind of the best practices, maybe some kind of the questions where you Google it also, you may not get those kind of the questions. It is purely your understanding, your implementation kind of the perspective. So the point here, guys, that 30% edge is nothing but your testing. So out of 100 record, 70% is for the training, 10%, 30% is for the testing. That might be either 75-25, 80-20. It all depends, guys. Like, sometimes if I'm increasing the training, and definitely it is affecting my testing. Sometimes I'm decreasing the training and I'm increasing the test set. Definitely I'm going to get some sort of the betterment or even less outcome. It all, you have to venture that. Again, I'm saying it all depends on the data set. It all depends on the algorithm you are using. It all depends on the domain you are working for. And of course, nevertheless to mention, it all depends on your hyperparameter tuning technique also. So just to see the way how we are writing the code, only you need to understand these terminology, guys. X test, Y test, X train, Y train. Okay, train test split, all these kind of things. Otherwise, the program is simple, like from importing and as well as assigning all the values to, because there is a possibility of assigning multiple values to multiple variables. That is one of the advantage with Python. Now feature engineering, as I said, guys, and in some kind of the cases, your feature engineering is coming under the category of data pre-processing. Some people perform this feature engineering before the train test split. But however, okay, it is all your wish. As I said, there is no hard rule or code book to follow the practice of the data science. The data science itself is a practice. There is no kind of betterments or of course best practices would be there by companies, and those are all the standards, but still they are all references only, guys, not the mandatory things to follow. Though you are following also, in your case you may not get the expected outcome. It all depends. Like the feature engineering here is displaying the categorical data and numerical values whatever I am having, and then just this is also some sort of imputing the missing values. And how do we perform that, because some certain aspects are there to handle the missing value. Maybe I can replace with mode, replace with the mean value, like this, guys. Suppose age of the member while recruiting, maybe we are recruiting some 150 members, assume that, and for 135 members, maybe all engineers from various states of India, and more or less they're having a similar age group, 2021, like that, maybe less than that or near to that. So if you are considering, guys, maybe 10 members, they have not updated their age and we don't have the time to contact them. Maybe they deputed to various places and we need to individually contact them. Rather, what you can do is we can find out the mean of the entire group, 150 group, so that mean can be pasted in the missing values. Maybe more or less 2021 only, na? Maybe he's having 20.5 years or 21.3 years, like that, the appropriate mean. And mode value, sometimes there is a repetition of the corresponding thing and I want to substitute that more number of times repeated. So these missing values imputation helps us so as to substitute something inside the corresponding actual data. So what it does is rather than contacting manually, or sometimes as the case I have given, at least we can contact those members. But whereas sometimes, guys, the data might be something like credit card transactions, or else where they won't reveal any address or any mail ID or customer ID of the members. It's not our business to track them. But as a data scientist, we need to substitute by discussing with all SMEs and all these kind of the members. We have to come up with some kind of the analogy where you are performing some kind of the substitution, a meaningful substitution. Okay, so that is how you can refer. But here also the same kind of the for loops, all these kind of the in uh, what I mean to say here is, guys, your programming skills are definitely helpful and you need not reinvent the wheel. Only the thing is you need to pick up the appropriate convention where your implementation and all these things remain same, except that some kind of one hot encoding. Okay, and how do I fit the data? How do I transform the data? See here, guys, your training phase, fit. Okay, fitting the data is nothing but just we are preparing the model. This extrain is your model now, encoder. Just we are encoding it, in fact, and encoder transform. Just we are transforming this, and thereafter, guys, the actual scaling, of course, scaling, standardization, normalization. I'm trying to show you the training of the model. This is hardly 2 or 3 lines, guys. Just I am taking the naive base, and within that naive base, I'm having the type Gaussian, and we are referencing this and related to this Gaussian NB, just I'm having the reference. Now with this reference, I am implementing my model. This is actually your model, guys. One liner fitting the model. So, and that too, to fix the model or to fit the model, we need to use the X-train and Y-train, because there we got 4 outcomes, na? X-train, Y-train, X-test, Y-test. Your Y-test is the original data. Your Y predict is going to get, we are going to get the prediction. See here, Y prediction we are going to get. Now your Y prediction and Y test will be tested, because Y test is the original data. Y prediction is your implemented data, your model data. Now what you see here, just we are comparing these two. Y test is the original data, Y prediction is your model data. So just by comparing these two, we are getting some accuracy around 80.83. Okay, so guys, with your typical Python coding skills, only the thing you need to learn is along with this particular Python coding, you should learn the terminology and as well as the appropriate data pre-processing techniques and as well as the libraries. Plenty of libraries are there, friends. Fine-tuned libraries are there. Thanks to the researchers, they are striving for us. They are giving many kind of the flexibilities to us. Just what we need to do is we have to identify. Okay, we have to identify what exactly our requirement. According to our requirement, how we are performing the activities. Okay, and related to your domain, related to the appropriate case study or kind of the implementation, you have to select the corresponding algorithm. And then the flow is simple, loading the data and applying the pre-processing techniques. And thereafter, once your data is ready, then you are going to apply some algorithm just like this. And then your fitting of this particular model is your fitting of algorithm on top of extrain and y train is your model. Once you come up with your model and you can predict your model, predict the values. Okay, whatever the y test, x test, y train, x train we are having, now there is a chance of comparing, okay, between y test value and y predict value. In 81% of the cases, your y prediction could able to correctly observe y test. Okay, that means 81% of accuracy out of 100, 81% accuracy is there. Okay, and like that, some other aspects are there where you can you will be given some sort of other models, fine tuning and all. And then we are coming up with some overfit and underfit, which is very, very important, guys. Okay, because these terminology is not cannot be completed in 3 hours or 6 hours, guys. It is a, as I said, it's one kind of the body language. Machine learning is a kind of the body language. Big data is kind of the body language. So you need to habituate that. Okay, it's not like with the training or though I'm giving the training to you, you have to indulge into that. You have to discuss and you have to publish some kind of the articles. You have to speak something about that. You have to publish your blogs. You have to post some podcast related to this thing. And you know one thing, and we are enabling the members. If you publish some articles or if you publish some blogs, then definitely incentives are there, guys. Okay, just go and study the appropriate thing or else you contact your managers also. So definitely they guide you if you are very much interested to publish the articles. If you want to showcase your talents in the publications or learning, definitely you are welcome, guys. Okay, so just I'm opening up all the avenues which are available for you so that you can have a look and get that opportunity of exploring yourself. Okay, and likewise, guys, we're having all these kind of things. And apart from those things, metrics, because with this, I'll stop, guys, and then I'll take up the questions. Otherwise, you can have a break. So though your model is excellent and you are very much satisfied with your model, but you need to publish the results. You have to defend the result in front of the client, in front of other team members. Because guys, here the point is, as you are a developer, you travel up to 3 to 4 months to implement some sort of the algorithms on top of the data. You are, complete in and out of the data and you are happy so as to maintain the convention of applicability. And you are having everything about that particular implementation. But it is a responsibility of the developer or data scientist or machine learning engineer to showcase the results and to explain and to interpret those results in front of the team members, in front of the managers, in front of the clients. That is the hierarchy. Now, in what way you showcase your results, in what way you are going to talk, because you cannot say the entire journey of 3 months or 4 months in a span of 30 minutes call. You should give that, okay, why you have selected this algorithm, what exactly your observations, how your observations are helping to understand the internal patterns and how it can be turned into the business. These are all the questions that the clients are asked, guys. It's not like, okay, what is your capabilities in data engineering or machine learning? Why you like random forest? They won't ask these questions. They ask why you have selected this algorithm. I am getting only 85% of accuracy. What is the reason? And your confusion matrix true positives are saying like this. What is that? Because see, some of the functional users, some of the users who placed as the functional users in the client location may have the technical knowledge also, guys. Definitely client won't miss out any opportunity to catch hold on that on ours. Okay, so you should be ready. If any member who is technically strong, you should be able to defend with your techniques only, guys, not with the debate or not with with the voice raising, nothing like that. Okay, raise your standards. Okay, just you come up with some analogy and you have to think through. Okay, and at the while explaining these kind of the aspects, you should have all these parameters in with your support. Like the metrics are nothing but the measures where they are helping us. Okay, like I have taken these things. So exactly these many false positives are there. These many true negatives are there. Okay, see guys, the true negatives, false positives. This is very dangerous. We have to reduce false negatives. Okay, true positives, true negatives, exactly. Okay, all these kind of the conventions, evidentially you have to show, and then only you can come up with some kind of the, because plenty of because this Seaborn and as well as the Matplotlib are having many display techniques, guys, visualization techniques. So whatever the implementation, two important things they prefer. The first thing, of course, unavoidable, numbers. Number speaks more. And of course, the images. This is for the sake of you purely functional users. This is for the sake of the technical users. Okay, so you need to explain these things, guys. You need not explain, I have implemented this, I have fine-tuned this. These are all the parameters. These are all the pre-processing techniques. Never mind. Those things are not going to help you, guys. They're not at all going to help you. But apart from that, you need to talk about which are all the statistical measures we have observed and what is the observation, how we are projecting your details through visually. Okay, so this is what the metrics. Okay, I'm using the precision here 93 and recall F1 score, support all these kind of the considerations, accuracy levels. Okay, believe me, guys. Of course, a few members might be knowing about this thing. Your Python sklearn library is one treasure. Even if you start today, until 3 months, if you explore, you become a pro. I can write it down. Without any blog, without any videos. If you keep on daily spending 1 hour on sklearn library understanding, and you can learn a lot more. Upfront, I can say sklearn. Just you see, guys, this is a treasure hunt for us. Excellent. Though we are with the PySpark orientation, but still the session from different BU heads is better you focus scikit-learn. Like that, I got the notion. So that's what the reason explicitly in the SR document also we have mentioned that we are dealing with scikit-learn. Of course, after some time, definitely we'll embed that MLlib also, because MLlib is good, but not as much as good compared with scikit-learn, because scikit-learn is a fine-tuned version and where we are getting all the possibilities of exploring in the simplest way. MLlib is also not equally performing well, guys, but little more programming efficiency is required to implement the MLlib, and moreover, additional steps are also required. Vector assembler, all these things. Directly we cannot pipeline. We can add, we can make use of some additional packages and methodologies so as to perform that aspect. Now you see, guys, this is one where our Gita, Bible, or whichever. Okay, so just I'm pasting this. Have a look on this thing, guys. Okay, which is very, very required, which is very, very important. Now classification, regression, clustering. Nicely they have arranged dimensional reduction, model selection, pre-processing, and community mainly. Okay, just I request you to follow up this particular community, because these things really helps you guys. Okay, they're having all the avenues for us, whichever the avenue you feel good, Stack Overflow or whichever. So just you mailing list, blogs, all the things, friends, whichever possible, just to have a look on this. Okay, really they are the one we need to thank, because they are making our life easier. And latest news, what they have published on all these kind of the things. Now, if I'm clicking this pre-processing kind of thing, majority of the data engineers landing page, this is standardization. Okay, that is one technique. And purely, guys, you need not go here and there. Simply sit back, relax, open this website, official website of scikit-learn, have a look, practice, and come up with your understandings. Okay, so this is how you are going to learn and perform the activities. Normalization, standardization is different, encoding the categorical. Okay, this much is enough, guys, actually, for every machine learning engineer or data engineer, by exploring all these sub articles or whatever the things. Even we won't do everything, guys, here. But if you could able to understand these particular things, it's more than enough. Okay, such as I cannot say it's easy or simple, but your commitment and continuously engaging with these kind of the terminologies and all, definitely will be getting the convention. Okay, now especially if you, as we are after the break, just we are coming back and talking about the flow and all, there are certain aspects, guys, like support vector machine in terms of classification. They take some example and they're going to give all the implementations for the multi-class classification also, and how we are going and how we are managing the unbalanced data. And all the friends here, even client, if he is asking in the evaluation call also, definitely those questions will revolve around this thing only. And believe me, your other bloggers, other machine learning practitioners are getting the source from here only, but they are writing in their own language. Because one simple technology or technique, don't again go back and start from the zero. Okay, just already the content is there. Understand this particular content, project the content according to the flow, according to your flow, your observation. Because always Xerox is um, we prefer Xerox only, na, rather than the original. So similarly, just you go through, but that Xerox should be from the authenticated one, guys. That should be mandatory. Okay, Xerox is okay, but only the thing is you should take that Xerox from the authenticated version. Okay, if that original document is not authenticated, then your Xerox also not authenticated. So whatever the language, whatever the blogs or whatever the articles you are writing, they should stick on to these particular authenticated versions. Okay, so just a little heavy topic, guys. Definitely, I do agree. But only the thing is, I want to show you the essence of the machine learning orientation. Definitely in the machine learning aspect in detail, we are going to talk to simplify this machine learning thing so as to get back our engines to idle stage. I'll give only the names of the algorithms after the break. Then we'll take one or two questions related to our Databricks examination, so that it will create some kind of circle so that we can wind up the session without any delay. Okay, so that's all, guys. Thank you for your patience, and we'll be getting back by 20 minutes from now. So just if you are having any doubt, let me see any doubts are there. I think, yeah, no doubts were there. If you are having any doubts, who is that? Sasikant, tell me.
Yeah, sir. So, sir, basically, in data science, we have to, facing some lot of issues with missing values, right? How we can
Ah,
impute the missing values. Sometimes
exactly.
we struggle to, which should be the best approach to feed mean over mode or median. So,
Ah,
do you have any thought, which should be a best fit to on
yeah, yeah.
do you have any case where mean is good, median is good, mode is good?
Exactly. Exactly, Sasikant. I know actually what you are where you are coming from.
Hmm.
Luckily, I got some case study, guys, because some of the senior members in our company only we are teaching. Have a look on this, guys, because exactly in line with your question. Luckily, I'm having the literature with me.
Nice, nice, nice.
filling the missing value thing, guys. I have taken one example, Shashi here. So, the first aspect is, however, we are talking about the missing value here. Okay, we are observing how many missing values are there and all. Now, without handling those things, the accuracy comes like this. Now, what we are doing is imputation with additional column. Because as you ask, is there any possibility of implementing or imputing the missing value? There are certain possibilities where I can apply the missing value imputation, and thereafter, before this particular thing, uh, deleting a row with the missing data. Suppose if your data is greater than 30% missing values, then you can delete that. Even SME suggests that point also, guys. The very first aspect, if you consider, okay, there are multiple things, guys, in the missing value imputation, where deleting the columns with the missing data, deleting the rows with the missing data. Now the third and most frequently used, okay, filling the missing data with a value. Maybe that is the mean or median or mode or whichever. And next important thing is imputing the appropriate missing value with the additional columns. And even one surprise is there, guys, with the even with the algorithmic aspect also, you can handle the missing value. Okay, not always deleting or removing the appropriate missing value may not serve our purpose. Rather, what you can do is either you can substitute that particular missing value with the help of the mean, median, or mode, or else nowadays, guys, this is also famous. Let me show you. Just I'm having the missing value, and what we are doing is we are deleting the missing value literally. Just we are deleting this particular value, and then we are with the programmatical aspect we are dropping. Now we are seeing no missing value is there. Now what we are doing, we are implementing, we got some 79.4 accuracy. So what I mean to say is after dropping your missing value, we can able to observe 79% of the accuracy. Now the second method, deleting the row with the missing data. Row, earlier we have deleted the column. Now we are deleting the entire row. Okay, now you can see that there are no null values as we have deleted the rows. But now the imputation here is 82%. Now you see, guys, in the first example, we have only deleted the column information. We could able to observe the 79% of the accuracy. Whereas in the second scenario, I have not considered the entire row and I have deleted that row. You may ask this question. After deleting the row only, we are able to observe some more accuracy. So then, friends, I'm saying that we cannot generalize deletion of the row always gives the better accuracy. How you can say answer diplomatically is, guys, in this particular data set, especially while talking about this particular data set, we observed that after deleting that particular column which is containing the null values, I can able to see 79% of the accuracy. Whereas if I am deleting my entire row, I can able to see 82% of the accuracy. That means your row is not going to contribute to the algorithm or model. That is the analogy, guys. But it may not be true for other data set, especially whatever the data set we are taking may be related to that particular data set only. We are getting the observation of the deletion of row yields 82.3% compared with the deletion of the column. Whereas if guys, missing value imputation, you may be taking the mean value or you may be taking some kind of the default value. Sometimes, we are not sure whether I need to apply the mean or something. So in that case, some default value also you can apply. Suppose if I am not getting that data. Okay, so just you can maintain that particular thing with the default value. Okay, so within this particular case, I could able to see 77.98 accuracy. It may not be standard for everything, but at least for this particular data set, you can observe that. Okay, and similarly, in case of means not field. Okay, suppose if I want to perform some kind of the simple imputing with the programmatically, rather than deleting the column, rather than deleting the row, rather than substituting a default value, I am having most commonly used kind of the convention. I can go ahead with the substitution of mean value, mode, or median is more authenticated kind of thing, friends. Why I am saying authenticated is We are giving importance for the original data, whatever we are having in the data set. From that particular data set only, we are able to compute the mean values or mode or median, whichever, and we are substituting instead of the missing values, guys. So, and one more caution I am giving you, though it is authenticated, we cannot guarantee that definitely this particular method is going to give the better accuracy. In fact, why still data science is under force is due to this only, guys. No data scientist can say if you apply the mean, median or mode compared with the deletion of the column, compared with the deletion of row, compared with the default value substitution, you are going to get best accuracy. Never. I can prove that. Now you see, guys, here. Unfortunately, if you are substituting mean, mode or median in this particular data set, first we got 79, second we got 82, now we are getting 76, guys, which is less than your deletion of the column, deletion of the row and substitution of the default value. Hope you got the essence, guys. That means maybe the data set is one of the important fuel, and according to that particular data set only your techniques are going to reveal the data. It's not like the capacity of the testing. It is only the observation, based on the data set only we are going to capture the internal mechanisms, maybe the patterns or whichever the kind of the considerations. Okay, and now here you see 76% and filling with the regression model. And here we are deputing the linear regression so as to impute the value. Now we can able to register 83% accuracy, guys. Okay, so in the order, if you see 83% accuracy, we can able to see with the help of the with the help of the linear regression. Second thing is deletion of the row. Third thing is updating the default value. Fourth thing, removal of the column. Fifth thing, your mean, mode or median kind of the imputing. So especially in this particular case, in this data set, the winner is imputing your missing value with the algorithm, with the linear regression. This is the latest thing, guys, because we generally pick up either deleting the column or deleting the row, or else substitution of the corresponding value with the default, or else substituting with mean, mode or median. Okay, but nowadays, guys, practitioners are very smart. Na? They are going to impute this particular thing with the help of algorithms also. Okay, but of course, fortunately, we got higher accuracy compared with other kind of the models. Okay, so this way, guys, thanks, Ceci, because if you're asking these kind of the questions, however, as a practitioner of this data science, I'm having every case study and corresponding evidential document so that I can project in front of all you guys, so that you can also get some insights what we are practicing and what we are gaining day by day. Okay, nice. Any
Thank you so
other?
much, sir. Thank you, sir.
Okay, Ceci. Okay, Ceci, thank you. And keep me asking the question so that I can explore more. Abhishek says, how may I know when I need to drop the NA values and when to use fill NA? Yeah, hope now I answered your question, Abhishek, because if you consider 30% greater than that particular column is having the missing values, or 30% of your records every time registering some sort of 30% greater than null values are bothering us, then with the discussion of SME and as well as the statisticians, you can remove those kind of the values. In all the other cases, preferably either you can substitute with the default mean or median mode, or else latest you can substitute the algorithmic based kind of the aspect also, guys. Okay, nice. No more insightful audience are there in terms of machine learning. Huh? Hope I answered your question, Abhishek. Still, you need some more thing. Definitely, I'll prepare some case study and I will explore in front of you. Okay, right.
Yeah, thank you, sir.
Okay, ma. Okay. Any other? Any other? Okay.